Now we are going to solve the problem number 1, which is given in page number 218 in oscillation chapter. First I will read the problem. In a simple harmonic oscillation, the acceleration against displacement for one complete oscillation will be 4 options are given: an ellipse, a circle, a parabola, a straight line. Here the answer is straight line, but you have to understand the concept. Okay. So here, before going to see about the relationship between acceleration and displacement, in textbook itself, in page number 191, one graph is given. Okay, so here the graph is drawn between the restoring force and which one? The displacement. Here force is taken as cos and x is taken as displacement is taken as effect. Here the meaning is force is directly proportional to x. When x increases, what happens when restoring force also increases? And you can take in opposite form also. Are you clear? So when restoring force increases, that displacement also increases. So here these two are having the linear relationship. Are you clear? When x increases, when displacement increases, that restoring force increases in the opposite direction. That's why this part is drawn for displacement and this part is drawn for restoring force, and on the whole you will be getting a straight line. So here that restoring force and displacement both are directly proportional to one another. These two can be equated by introducing a constant called, what is this? Force constant K. So here that negative symbol shows that restoring force that acts in the opposite direction of displacement. So here K will be equal to which one? Minus F by X. Are you clear? So here that K value must be written in terms of negative. Are you clear? So negative value you will be getting. And then slope. How to get the slope in this straight line? So here draw the slope in this straight line, because force and displacement both are having the linear relationship. That's why you have got the straight line. After drawing the slope, so clear that x that falls in y-axis part and F restoring force that can be obtained in the x-axis part, difference in y that gives you x, difference in x that gives you F, that slope value that gives 1 by K, that is 1 by force constant you will get. To get the force constant K, the slope must be reciprocated. Only then you will get the value of K. So, are you clear? Force constant. Now this graph that is to be taken as the analogy to understand the relationship between acceleration and displacement. We know the fundamental formula. Acceleration is directly proportional to displacement in the case of simple harmonic motion. Are you clear? When displacement increases, acceleration also increases, but the clear acceleration increases in the opposite direction. The directly proportional symbol is replaced by introducing the equal symbol. Now we have to introduce a constant called, what is this? Omega square. Omega square is nothing, omega is nothing but angular frequency. A is equal to minus omega square y. This negative symbol shows that displacement and acceleration both are taking place acting in the opposite direction. Minus omega square will be equal to A by y. Look at the graph. When displacement increases in this direction, acceleration increases in the opposite direction. Are you clear? When this one increases, this one also increases, but both are taking place in the opposite direction. That's why this part to be taken for displacement and this part is taken for acceleration. Now in this straight line we can draw a slope. Slope formula is dy by dx. dy, in dy you will get displacement. In dx you will be getting the acceleration. Slope that gives you y by a. Are you clear? But a by y is nothing but minus omega square. From slope you will be getting the value of minus 1 by omega square. Are you clear? By reciprocating the slope you will get the value of minus omega square. Are you clear? Minus omega square angular frequency can be obtained. So this there in this graph force and displacement are drawn in the form of graph. Here acceleration and displacement are taken in x-axis and y-axis and the graph is drawn, and the shape of the graph will be in the form of a straight line. Are you clear? They have the linear relationship. Both force and displacement also having the linear relationship. Acceleration and the displacement also having the linear relationship with one another. That's why you have got the straight line. Okay, very interesting one. Know the fundamentals. There, reciprocal of the slope that gives you force constant. Here the reciprocal of the slope that gives you minus omega square. Little things, small things, the clear may be useful for deriving the problems. Okay, thank you.